Good evening, sir. My name is Sahil. These are my teammates Siddhant and Parth. Today we are going to demonstrate the Liang-Barsky algorithm for line clipping. Start.
Now I will explain to this generalized algorithm. This works on the parametric equation of line. As we know, for the parametric equation of line, we need a variable which is t over here. When t is equal to 0, that means that indicates the starting point. When t is equal to 1, that indicates the ending point. Over here, our main concern is finding out this point of intersection, which is x. Let us assume it is t1 when it is starting from this direction and t2 when it is starting from this direction. According to the algorithm, we need to find these 8 quantities from p1 to p4 and q1 to q4 according to this formula given over here. Then there are further conditions according to which we will determine whether the line is lying outside our screen, in between our screen. Let us see that which I have implemented in the code. So this is the code over here. Exactly the algorithm, I have declared x1, y1, x2, y2, which are the coordinates. The x min, y min are the minimum. 1 minute. Minimum coordinates. For example, if this is the screen, if this is the screen over here, this is the screen. Then this is the x min, y min, and this is the x max, y max. Now t1 and t2, as I explained earlier, are the parametric coordinates. We are giving it by default as 0 and 1 so that it indicates the endpoints. Now these are the 8 variables which we need to find. These are the fractions which we will require next time. These are the x1n, y1n, x2n and y2n. These are the new clipped coordinates. Now this del x del y is for simplification further inside the code. Now I'll show you few formulas which is required. This is formulas for p1, p2, and these are the conditions. If we directly find out if p1 is 0 and q1 is 0, or in the same manner p2 is 0 and q2 is less than 0, then that means the line has to be rejected, because that is either outside or it is parallel to the screen. Otherwise we'll go and further check the condition to update t1 and t2 according to these conditions. If any of p1, p2 or p3 is not 0, what we do is we find a fraction q1 upon p1 and see if it is less than 0. If it is less than 0, we'll update t1. Now t1 is equal to 0. If this fraction is greater than p1, then we'll update t1 to that value. In the same manner, we'll check for p2, p3, p4, and then afterwards, over here is the max function which I determined for checking that. In the same manner, there is one more condition to change the value of t2, which is finding the minimum, over here. As you can see, I'll again find f1. If p1 is greater than 0, then what it does is the minimum value. Now t2 is 1. So it will check the minimum value and give the value to t2. Now we'll run and show this. See, this is the line over here, which is, as you can see, I have drawn from here to here. Now I'll show you after it is clipped. I'll again show the output. So this is our clear line, and this is the clipped version of the line. So this is how the algorithm works. Thank you.